Simple harmonic motion. Simple harmonic motion is a movement that repeats back and forth through a central position, also called the equilibrium. So, the maximum displacement on one side is equal to the maximum displacement on the other side. The time intervals are the same on each side, and the force of the motion is directed towards the equilibrium position and is directly proportional to the distance from it. In this project, we will explain a problem given by our teacher, basing our knowledge in the previous investigation we've made. We will show you the statement of the project and the procedures that guided us to the solution. We also want to learn more about the simple harmonic motions and how to solve them, as well as how we can apply them in our real life.
Period refers to the time that is taken to do something. It's the time of the particle on a medium for completing a vibrational cycle. Frequency is a rate quantity. Period is a time quantity. Frequency is the cycles over second, and period is seconds over cycle. The frequency of a wave refers to how frequent does the particles of the medium vibrate always when a wave passes through it. On math, the frequency of a wave is the number of the complete vibrational cycles in the medium for a specific amount of time that is given.
The amplitude of a wave is the distance of its height, because that height is defined as the farthest distance the wave gets from the center to the top. Because the amplitude is defined as the distance to the center to the top, we can see that in here, in this graph, we can see that the largest distance is to 5, and also for here. So then we have the result of an absolute value of 5.
So, as we have seen, the longitude of our period goes from this point to this point. So, as we can see in the graph, from this point over to this point, there's a longitude of 2/5. So our period will be of 2/5. So as we can see, here is the formula for frequency. Frequency is 1/t, and t is period. So our frequency in this graph of this problem will be 1/2/5. So if we apply tortilla rule, our answer will be 2.5.
Finally, we have expressed the function in the form, and then we have the formula. So we are going to proceed to put our variables. So first, we have amplitude. As we already know, amplitude is 5. So we put 5 sine, and then W. How we are going to get W? Well, it's really simple. Here we have another formula. It's 2 pi divided into time. As we know, our time is this one, so the result finally will be 5 pi. So we put it here. And here goes time. As we already know, it is 2/5. And we need to simplify this equation. So the result will be Now we are going to see the applications of the harmonic motion in the real life. One of application is the pendulum. Here we can see that when we move the pendulum, it's affected by the gravity. So the pendulum starts to oscillate, and this one is a perfect example of a simple harmonic motion. Another example is the music. For example, on the strums of the guitar, they make different sounds. So each sound has a different sound, and that's also a simple harmonic motion. Finally, we have reached the last phase of the video. Throughout the video, we learn many things, such as how to solve a simple harmonic motion. We learn the formulas we need, and also we understood the variables. But the most important thing, we acknowledge that in our daily life there are many things. We also see many things, but the most important, they have a really complex process. That's the beauty of the maths. In this case, it was the simple harmonic motion. They are some waves or sounds we hear, and they actually are really complex to understand. That was part of the objective of our video. It was to also do a mathematical process, but also compare it with our daily life. So I would like to say thank you very much for your time. See you next time.